Hi everyone. So in this video we will start studying about demux. So a very easy topic, and I would say it will set the base of our next topic, that is a decoder. So let's start studying demux. Okay, so it is a single input and many output device. It is one to many circuit. That means there will be one input and many outputs will be there. So it is just the opposite of a multiplexer. In multiplexer, what was the scene? 2 to the power n cross 1. So there were 2 to the power n input and one output with n select lines. So here n select lines are there, one information would be there, and these many 2 to the power n would be the outputs. So these are total 2 to the power n outputs. 2 to the power n outputs. Okay, let's see one by one, and it would be more clear to you. What would be your 1 cross 2 demux? This is your 1 cross 2 demux. So what it says, if S is 0, then information will be transferred to Y0 and Y1 will be 0 only. And if S is 1, then this information is transferred to Y1 and this will be 0. So how you can write Y0? So Y0 is, if S is not there, then your information is transferred. And what is your Y1? If S is there, then information is transferred. So this is your S bar I and this is your Si. I hope you are comfortable with that. What about 1:4 demux? So if S1, S0 both are not there, then this information will be transferred to Y0 and rest all will be 0. If this is 0 and this is 1, that means then information will be transferred to Y1 and here information will be transferred to Y2 because decimal equivalent is 2, and here information will be transferred to Y3. So how Y0 can be written? If S1 is not there and S1 is not there and S0 is not there, then information will be transferred. If S1 is not there but S2 is there, then information will be transferred. If S1 is there, S0 is not there, then information will be transferred. If both S1 and S0 are there, then information will be transferred. Can I write it? Can I write this as M0 I if my function is of S1, S2? If something is a function of S1 and S2, then I can write M0 I. This I can write as M1 I. This I can write as M2 I, and this I can write as M3 I. Say yes or no, right? Similarly for 1:8 demux, if S0 is not there, let's start from S2 only because S2 is the MSB. So if S2 is not there, S1 is not there and S0 is not there, then my information will be transferred. If S2 is not there, S1 is not there and S0 is there, then my information will be transferred. So basically I can write this as M0 into I, M1 into I, this would be M2 into I, this would be M3 into M4 into I, M5, M6 into I and M7 into I. Okay, so this is your simple demux. This is your 1:8 demux. Okay, very easy question, very easy thing. Now with the enable input, how will you write down the output? Tell me. So forget about enable. So if S is not there, then information I will be transferred. But considering that enable is 1, considering that enable is 1, because this is what? Active high enable, right? Active high enable. And what about this? If S is there, then I will be transferred, considering that En is high. What about this? If S1, S0 both are not there, then information will be transferred, considering that En is 0 because this is active low. This is active low. Considering that En is 0, so here I will put En bar. If En is 0, then this information will be transferred. If En is 1, the circuit will not even be working. If S1 is not there but S0 is there, then information will be transferred. If S1 there, S0 not there, information will be transferred. If S1, S0 both there, then information will be transferred. Okay. Now there is a question, you need to find all the outputs. Okay. A and B is there and this is I. So how I can write Y? If A is not there, B is not there, then I will be transferred here. If A is not there but B is there, I will be transferred here. If A is there, B is not there, I will be transferred here and here this. Now I am taking, now how I can write this one? M naught into I, right? Now I am taking the bar. So if I take the bar of A bar, B bar into I bar, can I write it as X into, this is my X, this is my Y, X into Y bar, right? I can write it as X into Y bar, that can be written as X bar plus Y bar. So this can be written as A bar, B bar, bar plus I bar. Say yes or no? Are you getting this point? Now A bar, B bar can be written as A plus B bar. Very interesting result we are going to see here. It can be written as A plus B bar, and A plus B bar another bar. What that would be? M0. Basically A plus B, we are getting A plus B. A plus B whole bar got cancelled. A plus B plus I bar. So what is this? Capital M naught, right? Plus I bar. So here you are having M naught I, M naught I, you are having M naught I, and if you took bar of this, what did you get? M naught bar plus I bar. And what is M naught bar? Capital M naught plus I bar. How M naught bar is capital M naught? Because if M naught is there, and if I am putting bar, that means M1 plus M2 plus M3, right? M naught bar means 0 will not be there, 1, 2, 3 will be there. And what does this mean? That my min terms are 1, 2, 3, then what will be my max term? M0. In the assignment problem, we saw a question like this, if you remember assignment 1. If M naught is not there, that means 1, 2, 3 are there. And if 1, 2, 3 are my min terms, then what will be my max term? This, right? So, if the output of this is M naught I, then here output is M naught plus I bar. What will be the output here? M1 plus I bar. What will be the output here? M2 plus M2 plus I bar. And what will be the output here? M3 plus I bar. And what will be your M1? M1 will be A plus B bar plus I bar. Say yes or no? M1. M1 means 0, 1. So A plus B bar plus I bar. Right? What about this? A bar plus B plus I bar. A bar plus B bar plus I bar. So this would be your output. Now let's see a very interesting point, that is active low demux. Active low demux. This question that we have solved, that will be used here. Active low demux. So there could be other active low devices as well. When we study decoder, there will be active low decoder as well. Okay. So what do you mean by active low decoder? So what was, forget about this active low sign, forget about this sign. So what was the conventional way? If S was 0, I would be transferred to Y0 and Y1 would be 0. Just the opposite of, just the inverted of that will happen, because inverted sign is there, no? So if S is 0, information I will be transferred here, but inverter sign is there, no? So Y towards the Y0 I dash information will be transferred and Y1 value will be 1. If S is 1, then I information would have been transferred to Y1. This is my final Y0. Here I am not writing Y0. Basically, this I am not writing. Now, this particular thing is my Y0 only. So here there is something else. So what is that Y0 dash? What is that Y0 dash? That I know. What is that Y0 dash? That Y0 dash is, if S is not there, then I will be transferred. But opposite of that will happen. If S is there, then information I should be transferred here, but I bar will be transferred, and this should be 0, but this would be 1. Just consider this as an inverter only. This question and this question is same. There is just inverter connected. There is just another inverter connected, nothing else. Active low means active low demux. That means one another inverted connected, nothing else. Okay. So how will you write y naught? So y naught I can write S plus I bar. Say yes or no. And y1 I can write y1 I can write S bar plus I bar. This is your y1. So this is here. So S bar plus I bar. And for y naught, how am I writing it? Look, what is my y naught? Y naught would have been S bar I naught, right? Just take I naught, sorry, I only information. So just take a bar of that. So S plus I bar. What about y1? Y1 would have been S into I. Just take bar of that. What you will get? S bar plus I bar. Okay. So from here only we can write in this manner. Well and good. Or if you directly want to write it down from the max terms, from max term also we can write it down. So when it is I bar, I will not look at 1. If you remember the table, like we used to put here AB input and then the output, then there would be combination, and then these would be the outputs. Then I would only look at 0 if I am writing from the minterm. So I would write y naught is equals to a plus b. So similarly, I will only look at the minterm, that is s. So I will not look at 1. I will not look at 1. But if let's just say in some question there is c available as well. So how will you write down the output of this? So a plus b plus 0 into a bar plus b bar plus c, because this is a bar, b bar plus c. Similarly, in this manner, s plus I bar, there is no 0 available again. And what about y1? S bar plus I bar, because this is S bar. This will represent S bar and this will represent S. In max term, in max terms, right? If you are not able to understand this, forget it, no need to worry. You can derive it in this manner as well. Just consider a simple bar there and you will be able to write it down. But you should have the concept clear. You should be able to write down if you are able to write down the output of this, then why not this? You are able to write down the output of this. Y naught will be a plus b. I am writing in POS form, a plus b plus 0. Output is 0. This is how I told you. This is how we write the output. 0 we will not write. A bar plus b bar, plus c. We can write for these one as well, like a plus b bar plus 1. But this plus 1 is there, so it will become 1 only, no? So that's why it is not written. That's why this 0 is not written. In the basics we studied it, how to write down the output using minterms and max terms. So this is what we are using. But we are habitual of writing the outputs using minterms, but not max terms. So that's the thing. That if minterms were there, you could have easily written the output, because we are habitual now. But for max terms, sometimes we are not habitual. So that creates some problem, but you can always take a bar, right? So this could be the answer. Let's write down the answer here. Okay. So how will you write it down? So I will write down in this manner in the examination, that if S1 is not there and S0 is not there, the information I would have been transferred, but there is a inverter, so bar. So S1 plus S0 plus I bar. This can be S1 plus S0 can be written as M0 plus I bar. What about this? If S1 is not there and S0 is there, then information I would have been transferred. So S1 plus S0 bar plus I bar. So M1 plus I bar. What about this one? This would be S1 bar plus S0 plus I bar. That would be M2 plus I bar. And what about this? S1 bar plus S0 bar plus I bar. So this would have been M3 plus I bar. Well and good. Very easy. Okay. Let's solve some problems now. This input 1 is given, AB is given. You need to find the minterms of YA and YB. So if this is Y0, Y1, Y2 and Y3. If A is not there and B is not there, then information 1 would have been transferred. If A is not there but B is there, then information 1 would have been done. Basically multiply 1 is also there. Then both are added. So A bar B bar plus A bar B, that would be A bar only. Till this time you should be comfortable with these kind of calculation. It would be A bar only, right? This is A bar. And here you are having A bar B, right? So now your YA is A bar XOR with bar of this, right? So like you can make it XNOR gate, but why we should make it XNOR gate? Let's solve it directly. Or what could be the easier way? If I do A plus B here, it would be of no use. Let's solve it. Let's just solve it. So first as it is bar of second plus second as it is bar of first. So what I am getting here, A bar B plus A plus B bar into A. So A bar B plus A plus AB bar. So this would be A only. A plus AB bar would be A only. So final answer I am getting is A plus B. And this is A plus A bar B. A plus A bar B can be reduced to A plus B. The final answer by A you are getting is A plus B. You can solve it any day, you can solve it, right? This is your A bar, this is your A bar B. So A bar XOR A bar B bar. So first as it is bar of second, second as it is bar of first. So A bar B I will be left with A plus B bar into A. So A into A I will get here, and this is A plus B bar. So A will come common, so this will be reduced to A only. A plus A bar B would be A plus B. So this is what you are getting, and this is what? Capital M naught. So what will be the minterms? 1, 2 and 3. These will be the minterms, right? What about this? What about this? What you are getting here? You are getting here is A is there, B is not there. And what about this? You are getting both A, B is there. Multiply of both. What you will get? 0. A B bar into A B. What you are getting? A into A is A, B bar into B, 0 you are getting. So you are getting as answer as 0. So this was the method 1 of solving it. Very easy method, very easy question as well. Okay. So if answer is 0, yeah, tell me. Answer is 0. So what are the minterms? No minterms are there, no? Because always answer is 0. So if what they are asking, max terms of YB. So what will be the max terms? Max terms will be, because output is always 0. If output is always 0, then all will be the max terms. That is 1, 0, 1, 2, 3. Okay, so all will be the max terms. No minterms are there. So this is the output. This was just a simple calculation which we did here. Okay. So this is the answer of this. This is the answer of this. Let's see the method 2. What I can do here. What I know, this will be M0 into I. M0 into 1. And what is this? M1 into 1. This is M0 into 1. This is M1 into 1. This is your XOR gate. XOR gate, what it does? It will add them minterms. And here M1 will go. After the bar here, which all minterms you will be having? 0, 2 and 3. Here you are having M1. So after the bar you will be having 0, 2, 3. And here you are having M0 and M1. Here you are having M0. How did I say it will add? Do you remember what is the property of XOR? Sorry, what is the property of OR? A plus B. Remember the Venn diagram? All the minterms will come. So whatever that is here, whatever that is here. So M0, M1 both will come. Okay. We can write it in the form of addition as well. So, and what XOR gate? Now after the bar we have found M0, M2 and M3 are there. So basically this is your XOR gate whose input is M0, M1 and M0, M2, M3. So what XOR gate does? If you remember, XOR gate, A bar B plus a b bar. So everything but not common. So what is common? Common is m naught. So everything will come but common will not come. So m naught will not come. So m1 will come, m2 will come, and m3 will come. So in the output your m1, or you can write summation m 1 2 3. That's it. This is your output. So this is how you can solve it. And what about this? Here you are having m2 and here you are having m3. What this gate does? Takes only the common. AB takes only the common. What is common in between them? 0. What this gate is actually doing? Multiplying both, right? m2 into m3. What you get to know? That it is 0. What is the conclusion you can make from here? Something very interesting, not I wouldn't say very interesting, but very common, that multiplication of 2 or more minterms is always 0. Do you remember? Addition of all the minterms is 1. Addition of all the minterms is 1. Remember this statement? Multiplication of all the maxterms is multiplication of all the maxterms is 0. Multiplication of all the maxterm is 0, right? And here multiplication of 2 or more minterms is always 0. So addition of 2 or more minterms will be always 1. Okay, addition of 2 or more maxterms, addition of 2 or more maxterms will be 1. And addition, these statements I will repeat it again, don't get confused. First statement, addition of all the minterms is 1. m0 plus m1 plus m2 plus m3 would be equals to 1. This is the statement 1. Statement 2, multiplication of all the maxterms will be 0. Statement number 3, and multiplication of any of the two minterms, will always be 0. Statement number 4, this will come later on, okay, later on it will come. Addition of any two maxterms would be m0 plus m2 also you can do, or m1 plus m2, anything you can do. M1 plus m3 would be 1. Say yes or no. These 4 statements are there, which is very very important. Okay, in MSQ they can frame these kind of conceptual problems where they can put the statement and ask you the problems. Okay, in the examination if it is not clicking, just like let's just say in the statement it is written that multiplication of any two minterms will be what? Multiplication of any two minterms. So just take the example a bar b into ab, 0 it is there. Okay, that's it. Okay, in that manner you can go. And here also you can check the addition of two maxterms. So what is m0? That is a plus b. And what is m1? M1 is a bar plus b. So a plus a bar will be 1 and b plus b will be b only. So 1 plus anything will be 1 only. So always it is going to be 1. Okay, because 1 bar will be there, and if 2 bars are added it will always be 1. So this is the question. This was the method 2. This is also how you would have solved it. Okay, let's go to the next one. Now you need to find output ya and yb. Let's try solving it with some different method. You can solve it any day. Like let's solve it by 2 methods. So first one, we should go with the conventional approach. So how will I solve it? How I would have solved it if I had been a student, if I am going with conventional approach. So what I would have done, that if a bar is not there, b bar is not there, then 1 would come. So basically here it would be, if a bar is not there, b bar is not there, then 1 would come. But I need to take the bar because inverter is added. So a bar dot b bar bar, it would be a plus b, right? Because a plus b bar is equals to a bar dot b bar, and then bar is there, so another bar is there, so it would be a plus b. So here I am having a plus b. How can you verify? this is your m naught only, right? This is your m naught only. So m naught plus I bar is there. So I is 1. So this is your m naught. What it would be? This would be m1, which is a bar plus b. Is it correct? 0, 1. Sorry, a plus b bar. A plus b bar. And multiplication of both of them. A plus b, although it would be m naught into m1 only. Here I will get m naught into m1 only, but let's do it. So a plus ab bar plus ab plus 0. So this would be a. You are getting a only, right? You can do the multiplication, you will get a only. So this is a. What about this? Look, this inverter can travel here and this inverter can also travel here. A bar XOR B bar will be equals to what? A XOR B only. Yes or no? If this inverter is traveling here, this inverter is traveling here. Basically, this is the, this is what? This is traveling here, this is traveling here. So this is M2 XOR M3 only. Initially the scene was, it was capital M2 XOR capital M3. You can say this is your capital M2 and this is your capital M3. So capital M2 XOR capital M3. Capital M2 can be written as M2 bar XOR M3 bar. This is how it can be written. So two bars are there, so it would be simple M2 XOR M3, right? Could be multiple ways to solve the problem. This is what I am telling. So what this would be? A bar plus B, and what this would be? A plus B, and I need to take XOR of that. That would be a tough task for me because I need to take XOR of that. This is actually A bar plus A bar dot B bar because AB would be 1. So M3 is A bar plus B bar and this is A bar plus B, and take XOR of that. That is a tough task. But what did we reduce to? We got to know that this is your small m2, this is your small m3. This can also happen. So what does this function does? What do we call it? XOR gate. So what XOR gate do? Everything but not common. So this will deliver m2 plus m3 here. So what is m2 plus m3? m2 is a b bar and m3 is ab, right? So it would be a only. So very easily I got this is a. Are you getting my point? What I did here? So this will give me m2 plus m3. Here it will give me m2 plus m3. Am I doing it correct? Yeah, it is fine. So you are getting m2 plus m3 here because if m2 is there, m3 is there, then what XOR gate will do? Everything but not common. So everything but not common. There is nothing common. So this will be m2 plus m3. And what is m2? M2 is a. What is m2? M2 is ab bar, and what is m3? That is ab. So here you are getting a, and a XOR a is 0. So this is the answer. So smartly, like I will have to use these inverters in the examination. If I had gone for making this XOR gate, then it would be very difficult for me. Like if I had gone getting XOR of these two, then it would be very difficult, right? Well and good. Let's go here. This is your M2 and this is your M3 again. So M2 plus M3, YB is M2 plus M3. What will be M2 plus M3? 1 only. How? What is M2? M2 is A bar plus B. And what is M3? A bar plus B bar. So B plus B bar is 1. A bar plus A bar is A bar. B plus B bar is 1. So answer would be 1. So answer is 1. Okay. So YA is 0, YB is 1. Well and good. let's implement higher level demux from the lower level demux. So you will be able to solve these kind of problems in the examination. No need to worry. It seems like that it is a big problem, but we have reduced it. We have a lot of methods to solve it. I could have done more things here. What I could have done, that this is the scene no here. If I talk about this scene, so can I convert this scene into this? Surely I can, right? So here you are having M0 and here you are having M1. So M0 plus M1 bar you would have got, because NOR gate will just OR gate will just add it up and this will take bar. So basically you will get M2 plus M3. And what is your M2? M2 is M2, yeah, again the same thing you are getting, AB bar plus AB. So again you are getting A only here. So just multiple ways I am telling you, like in the examination, who knows which method will be useful for you. If you go by conventional as well, you will be able to get the answer. If you go like any method you can go with. Okay, in the examination these questions will not be difficult. Combinational is very easy and sequential is also very easy. Whole digital electronics is also very easy, right? So implementing higher level demux from the lower level demux. So you need to make 1:4 demux from 1:2 demux. 1:4 demux, that means there will be 4 outputs. Do you agree? 1:4 demux means 4 outputs. 4 outputs. So there will be 4 outputs. 1 output, 2 output, 3 output, 4 output. Now you have only 1:2 demux. That means 1:2 demux. 1:2 demux can take only 2 outputs, and this can take only 2 outputs. Now if 2 outputs are there, they will certainly have some input as well. Now there are 2 inputs, but you want only 1 input. That means these 2 inputs will work as a output of another 1:2 demux, right? They will work as the, there you go, and this will be their input. 1:2, 1:2, 1:2. They will have select line. Let's not write which select line is this. This will also have select line. This will be the information. So basically this was your block. This was the information. And this was the output. So I am saying this is my I0, this is my I1, this is my I2, and this is my I3. This is your 1:4 demux. This is your information. This is your S1, this is your S0. I0, I1, I2, I3. Now, which one will be S1, which one will be S0? Let's assume this one as S1, or this one as S0 and this one as S1. So let's take a random value. If I put S1 equals to 1 and S0 equals to 0, where I would expect what I am doing? Why I am writing Y0, I0? This will be Y0, no? Y0, Y1, Y2, Y3. Similarly these Y0, Y1, Y2, Y3. Y2, Y3. If I put S1 equals to 1 and S0 equals to 0, where do I expect this information to go? This information to go here. This is what I would expect, that my I would, because this is decimal equivalent 2, so my I would go here. This is what I would have expected, right? So if you put S0 equals to 0, this is 0. If S0 is equals to 0, that means this information will be transferred here, right? And if S1 is equals to 1, so here this will be its Y0 dash and this will be its Y1 dash. So if S1 is equals to 1, then this information will be transferred here. So whatever the information that is coming here, that is being transferred here, which is being transferred to Y2 only. So this is what you wanted. So here your this is y1 bar. So here your LSB bit will be near to the output. LSB bit near to the output. LSB bit near output. Just the opposite of mux. In mux, your MSB bit was near to the output. Let's take another example. It will be more clear to you what I am saying. Basically, this is your y naught bar. This is your y1 bar. This is your y naught bar. This is your y1 bar. So let's take another example. If I put both equals to 1. So if S1 is 1, that means this information will be transferred here, right? And if S0 is 1, then this information will be transferred here. So where did you expected the information to come? At Y3 only. So yes, it is coming at Y3 only. So that's correct. Okay. So this is how you implement it. What could be the shortcut method? You need to implement 1:4 demux from 2. So 4 by 2 plus what do you get? 4 by 2 is 2. 2 by 2 and 2 by 2 will be 1. So 1 we will not count. So 2 plus 1 basically 3 demux, right? If you want to implement this, so 8 by 2 what you will get? 4. 4 by 2 what you will get? 2. 2 by 2 what you will get? 1. So 4 plus 2 plus 1, 7 demux, right? What about this? What will be the answer? 511. Why so just 1 less? The same kind of thing that we have done in multiplexer, the same thing we are doing here. Nothing new. 1:16 I need to make. 1:16. So 16 by 4, 4 you will get. 4 by 4, that would be 1. So 4 plus 1, 5 will be required. What about this? You are making 1:32. So one type of mux we are having, that is 1:4. Other type of mux you can make on your own. So let's start with 32 divided by 4. So 8 you will get. Again you can divide by 4. Now you will get 2. So you can use another 1:2 mux. And this will be for 1:4 mux. Right? So basically 8 plus 2, 10. 10, 1:4 plus 1, 1:2. Not mux, yaar. Hola demux. I have the habit of writing it mux. Hola demux. Okay. So 1, 1:2 demux. So 10 and 1. What else could be there? What else we can do? Like there will be n number of ways, na? Our target is just we need to use 4. Rest all anything we can use. If I go by 32 by 8, so 4 by 4. So 32 by 8 and this is 4 by 4. So 32 by 8, that means 4 you need to use 1:8 mux and 1 you need to use 1:4 mux. So this is how this is also I could have done. Like at the question mark, this could also come, no? 4 1:8 mux. This could have done. This could be there. N value could be 1 and 1:8 mux and here 4 could be written. If I try by 36, so if I try by 16, so here I will get 2. So this I cannot try because I need at least 1:4 demux. Do you understand the problem? In the problem I am saying that I need 1:4 demux. I can implement my 1:32 demux like this, that I will use 2 1:16 demux and I will use 1 1:2 demux. Yes, I can certainly implement like this. But in the question it is asking that you need to use at least 1:4 demux. What else I can try? What else I can try? I can try with start with 2, 16, 16 then 4, right? 4 4 is 4, then 4, then 4. What you are getting? 16 you need to use 2:1 and 5 you need to use 4:1. So multiple ways could be there, just some possible ways I have written. Okay, multiple ways could be there. These are very easy question. Usually these are not asked. Okay, that's why we are not that much serious about it. Just very easy kind of problems. Usually they ask the question from multiplexer. Now implement the following function. So this we have seen. Now our next topic is implementing any Boolean expression using demux. So implement the following function using demux. That demux you need to use is a 1:8. Okay, 1:8 you can say, or 1:8. So you need to use the demux 1:8, and you need to implement the following function, that is 1467. Make all the possible design using active low and active high demuxes. Again muxes. Active low and active high demuxes. Okay. So I have the 3 select lines which I will put A, B, and C. A, B, and C. Where this is my S2, this is my S1, and this is my S0. What will be my Y0? Y0 will be M0 into I. If this is the information, this would be M1 into I. So better what I do is that I put this as 1. So my outputs will be M0, M1, M2, M3, M4, M5, M6, M7. And what do I need? Summation of M1 plus M4 plus M6 plus M7. So this will be my F. Now my question is this the only way you can implement it? Is this the only way? No, this is not the only way. Why so? What I can do is that I can pick 0, 1 is already there, no? So I can pick 0, 2, 3, 5. 0, 2, 3, 5. 0, 2, 3, and 5. I can pick these, connect it to an NOR gate. Basically what this will be, M0 plus M2 plus M3 plus M5 bar, and what that would be, M1 plus M4 plus M6 plus M7. So there are 2 ways, no? If you are having NOR gate, then you will do this thing. So this will also be F, A, B, C. Let's try implementing the same using active low demux. So if this I put 1, what will be my here? M0 I bar, and I is 1, so this would be 0. So I will be getting M0 only here. So these outputs are M0, M1, M2, M3, M4, M5, M6, M7. Right? Now what you need to make? 1467. Minterms are 1467. Minterms are 1467. So what will be the max terms? 0, 2, 3, 5. 0, 2, 3, 5. So these will be the max terms, and multiplication you need. So what you will use? 0, 2, 3, 5. All that to there you go. Okay. Or this should be written here only, and this should be your F, F, A, B, C. This will have these minterms or these maxterms, you can say. Now let's just say in the examination, if this circuit is given and they are asking you the minterms of F, A, B, C, How would you solve it? They are asking you the minterms of ABC. How would you solve it? You will say that, sir, this inverter can come here. This inverter can also come here. All these inverters can come here, right? So the scene is, if all these converters are coming here like this, in the examination they will ask the analysis, like they will give this circuit and they will ask what will be the minterms of F. Then what you can do? So this is the scene. So if this is the scene, that means I can replace this as all these inverters and then there is a bar. So you will say that, sir, M0 plus M2, small M0 plus small M2 plus small M3 plus small M5 will not be there. Its bar we will take. So answer will be M1, M4, M6, M7. So if you are not that comfortable with max terms, then you can easily solve it using min terms as well. Just carry it forward, carry this forward, carry this forward, carry this forward. So this will become this. Very easy now. If you are not that comfortable with max terms, because we do not see max terms much, but you should be comfortable. This is my thing, that you should be comfortable. But if you are not comfortable, then I am telling you the multiple ways. Now my next question is this the only way to implement it? No, this is not the only way. Which could be the other way? Which could be the other way? That your max terms in function f a b c. What was your function f a b c? Their max terms was 0, 2, 5 and 0 to 3, 5. 0 to 3, 5. 0 to 3, 5. Right? So what I can do? This would be equals to 1, 4, 6, 7 bar. Say yes or no? Screen को क्या हो गया? Screen lag तो नहीं कर रही. So yeah, it would be 1, 4, 6, 7 bar. So we'll take 1, we'll take 4, we'll take 6, we'll take 7. Multiply all of them. And take bar of that. That would be your function A, B, C. So there are 4 ways of denoting it. 4 ways we have seen, right? Now if you need to analyze this one, what you will do? I can introduce this inverter at the input side, and these inverters will cancel it. If these inverters cancel each other, then that means it is minterm y1, minterm y4, minterm y6 and minterm y7, and this is what you wanted. Minterm 1, 4, 6, 7, right? So this is how also you can analyze it. In the examination, there will be multiple ways of analyzing it. So that's it. This is about our demux. Demux is also completed. Now we will move to encoder and decoder. So I will see whether we need to pick an assignment first or we can do encoder and decoder, because most of the problems we are already dealing in our course itself. So let's see whether I would make an assignment or I will go with decoder and encoder. So better we should go with decoder and encoder, so that we can start. Let's see what we are going to do.